So we saw how to use Excel to find probabilities for a standard normal distribution, and there's also an Excel formula that we can use to find probabilities for a general normal distribution when we're not just working with z-values. So we can always take our general normal distribution, I'll call it X, where we find our mean and our standard deviation, and we can always find the z-values and convert this into a standard normal, but it turns out we don't always have to do that to be able to calculate probabilities in Excel. So when we were dealing with the standard normal, we used norm.s to indicate we had a standard normal, and then we did .dist to find probabilities, and we plugged in our z-value, or Excel calls it an x. I'm going to use z. And then we put cumulative as true. Well, if I just have a general normal distribution and I don't want to convert to z-values, then I could just lose the .s and use norm.dist, and I could plug in the x that I want to go up to, and then I would need to tell Excel what my mean and standard deviation are. And then again, I would still want to use true for cumulative, or 1. And so here, if I'm not using the .s, I just have to tell Excel what the mean and standard deviation are. And I could still do this for a standard normal. In a standard normal, I would just need to tell it that the mean is 0 and the standard deviation is 1, and using the .s just saves me some time from telling it that the mean is 0 and the standard deviation is 1. And so let's look at exercise 13 and see how we would use this norm.dist to find some probabilities. So this says that we're assuming that the average height of 5-year-old girls is normally distributed, and the mean is 108.32 centimeters, and the standard deviation is 5.6. And part A is asking us for the probability that a randomly selected girl's height is at least 97.66. So if I draw my curve, my mean is the number in the middle, which is 108.32, and 97.66 is a bit to the left, and I want the probability that I get at least that value, which means I'm looking to the area to the right of 97.66. So in Excel, since I'm looking for the area to the right, I would do 1 minus, and then I would do norm.dist. I'm not putting the .s because I haven't found a z-value. And then I would put in my 97.66. And then I would need to tell Excel my mean and standard deviation. So I'll need a little bit more space here. So my mean is 108.32. My standard deviation is 5.6, and then at the end I'll put 1 for true. So this whole thing would give me that area to the right. And if we plug this into Excel, we should get something that's a little bit bigger than 97%, so a little bit bigger than 0.97. And a different way that I could have done this same problem is I could say, well, if I convert this to z-scores, then in the middle I'll have 0, and I could find the z-score for this 97.66. So to find the z-score of that number, I would do 97.66 minus my mean, and so this is why I will have a negative number, because I have something smaller than that mean, and I would divide by my standard deviation. And so I would be looking to the right of that z-value. And so something that I could have done in Excel is do 1 minus norm.s.dist, and then instead of plugging in the 97, I would plug in the z-value. So whatever it is when I do 97.66 minus 108.32, this is getting very big, over my standard deviation. And in Excel, if you're typing all of this in, make sure to put parentheses around everything in that numerator. And then at the end, I would put true. And so here, I'm kind of I don't need to tell Excel the mean and standard deviation because I'm using the .s. And in the previous version, I did need to tell Excel the mean and standard deviation, and then I just kind of let it do the other work for me. So both of these are valid ways to find that probability. In part B, it's asking for the probability that a randomly selected girl's height is between two numbers. So between 107.22 and 109.94. So again, we still have the mean in the middle. We still have this 108.32 in the middle. And now we want the probability that we get something between 107.22 and 109.94. So I want this area right here. So this would work the same as it did when we found the area between two z-values. I would do norm.dist, and I would plug in the bigger one, so 109.94, and then here I will need to tell it the mean and standard deviation. So I would need to type in 108.32 and 5.6 and true, and then I would need to subtract the area to the left of the smaller value. So norm.dist of 107.22. And then again, I would need to tell it my mean and my standard deviation. But it's the same process that we had before. And so this would give me the area between those two numbers. Next, I want us to practice these several exercises that are listed as practice activities just to get a little bit more comfortable finding these probabilities. So in part A here, it says we have a normal distribution and our mean is 135 and our standard deviation is 22. And we want the probability that a randomly selected value is more than 40. So 40 is here, and so that means that we're looking for the probability that x is bigger than 40, which is the area to the right of 40, which means I would need a 1 minus out front. So it would be 1 minus norm.dist of 40, 135, 22, true. In part B, it says we have this same distribution, but now we're going to be looking at the probability that we get something less than 90. So here it's asking for the probability that x is less than 90, which is an area to the left. And so we would do norm.dist of 90, and then our mean and standard deviation and true. And then lastly, we want the probability that our random variable is between 120. So here's 120. So between 120 and 180. So we want the probability x is between those two numbers. So first we would plug in the bigger one, and we're going to want to use norm.dist. And I'm going to write out what I would do, and we see if that's anywhere on our list. So we would do norm.dist of 180, and then we would plug in our mean and standard deviation and true. And then we'd subtract norm.dist of 120, and then our mean and standard deviation and true. But if you look at the options, this doesn't look like one of the options. None of our options have exactly what I have written here. And it looks like a lot of our options have a norm.s.dist. So a different way we could do this is to find the z-scores for these x's that we're looking between. So we could find the z-score for 120 and the z-score for 180. Try doing that and then seeing if any of these options match what you would get if you thought about this using z-scores instead of doing what we did right here. So it's just trying to get us to think about a different way to do this same problem. And if you finish that, take a look at these next few just to get a little bit more practice calculating probabilities. So take a look at all of these problems through number 18 to practice calculating these. And the last two, you'll need to actually try typing them into Excel to see what number that you get, and then you can check to make sure that you're getting the correct answer.